last week, we stopped at what is work. Again, some do not create work. Just need to be careful. Some of the work do not. Some of the force do not do work. Right. And for rigid body, need to pay attention to moment. Moment will do work. Moment multiplied by the angle traveled. That one is in radian, not angle, but is in radian term. Okay. We start to introduce you the principle of work and energy again for rigid body. You learn about this one during particles. What is principle of work and energy? You look at the name, you deal with energy, you deal with work, right? And the purpose of using principle of work and energy is usually is to find velocity. So what link with velocity is kinetic energy. So there's no potential energy here unless you're seeing conservation of energy. Conservation of the energy, you look at the change of energy. So then potential energy will come in. Okay, so we start to look at principle of work and energy. You're very familiar with the one you see on the screen here. T1 plus work done equal to T2. Okay, you're very familiar. So here, you look at rigid body already. So rigid body, you have a rotation motion. Rotation motion means you have moment already. Okay, moment, you have internal moment and external moment. Okay, all right. So what is work of the body? Internal force do not have to be considered if you use this visible work of energy. Okay. So if you look at this diagram, you see spring with a K value, with a fixed spin, with this external moment, radius 0.2, and you should able to draw free body diagram and kinetic diagram. So you're given the M for the disc supported at the center, and again you have a rigid body, so you need to calculate the second moment of inertia. Second moment of inertia, you have center of mass IG. This one you refer to graph of table. If you have an external point outside from the G, I label as O, you have IO equal to IG plus MD squared. So moment created at G point will be different from the moment created at O point. Okay, so if your O point and G point are the same, then you use IG formula. Okay. So here, determine the angle through which it must be rotated to attain angular velocity 2 radian per second. So how many angles should you turn the disc so that when you let go, you get the angular velocity omega 2 radian per second. This is start from rest. So you need to turn clockwise so that you charge the spring, so that the spring will pull the disc, rotate at anti-clockwise 2 radian per second. Make sense? Okay. From the rest, it add upon by constant couple moment 5 Newton per meter. There's an external moment there. Okay. The spring is originally unstretched and the cord warp around the rim of the disc. Okay. So here, you calculate by using free body diagram and principle of work and energy. So you look at the disc. This, you start with center of mass. You have W. Again, when you do your test in rigid body, remember you have a weight. Because when you reach chapter 7, most of the time in test 2, I see student, you can do all the external force, but in your free body diagram, you will forget your weight. One of you will forget your weight in your free body diagram. Because you are so concentrated in external forces already. Okay, so don't forget. And this was pinned to a O, so you have O, X, and Y. There's a force there. Okay, you'll be seeing pin in your coming assessment. So this one automatic, you need to add inside your free body diagram. And there's an external moment M clockwise. What else is missing? Spring force where? Where you put your spring force? Huh? Where? Left side here? Go up. Why go up? You imagine you're the disc. You rotate moment clockwise. What do you feel? Yes. You feel the spring punching in or pulling out? Yeah. You feel the spring punching in your body or pulling out from your body? Pulling out, so how come it go up? Huh? You imagine you are the body. The moment this way. What do you feel? You feel the spring punching in your body or pulling out from your body? Pulling out, huh? Here pull out. What? Why go up? Can you imagine? Just now your answer is go up. How come go up? How come go up? It should be go down. What? Understand? If you put go up, it means you are feeling the spring is punching your body. So it doesn't make sense. It should be pulling out, right? Okay. So the F spring is pulling down. You must always remember you are that object. What happens if you're that moment? What do you think? What do you feel? If the force punching in, then the force going in, right? Okay, so you pull in the principle of work and energy. It's starting from rest. So kinetic energy from rest, you write T1 equals 0. Important. If you don't write this one, I don't give you marks. Even though you substitute 0 here, I don't give you marks. Remember, you will see when I give you to see your test one. If you don't write formula, I won't give you marks. You get a very, very low marks for that question. All right. So T1 equals 0 because it start from rest. You remember this is important if the question start from rest. So T2, you have rotation. So you have I omega square. This is kinetic energy. So kinetic energy with the omega, you need to write T2 half IO omega square. How to get this one? You need to refer to the previous slides. Okay, I don't go back to explain this one anymore. Okay, you substitute the IO. This one you refer to O at the center of gravity, refer to graph, refer to table. They give you half mr square, or you'll see ml square. So just copy. Omega 2 square here is you need to find. I've seen students They write this one, when they do the next steps, they forget the square. They forget to carry the square for the next steps. For test one, I seen this one in one of your answer. Either one of you. Okay. So you miss the square, the answer is wrong already. I don't need to mark already. Okay. So you will see this graph. You will see this one in circular, this in the diagram, in the graph. So this one pin at the center, so we start at G. Okay. G is z point, so half mr squared. Okay, you're looking at the top, that's why you at the G z. If you look at the side, then you use xx, iy, then you use this one. Okay. If you look at this point, z prime, then you use this one. Okay. You substitute all the value for T2. Okay. You get 1.2. Why? Angular velocity was given. Omega was given. You're able to find in joule. Okay. Unit is important. Again, if you don't write unit in your answer, 50% discount from the answer. Sometimes I don't give you marks. If the answer is 1 point, I don't give you marks. It's either full marks or no marks. I don't give 0.5, 0.7. I don't give decimal place off. Okay. So calculate work. We have complete T1, T2. What doing work on the free body diagram? Which one doing work? Huh? Moment do work. What else do work? Spring do work or not? Why no? What is work? What is work? Same direction ma. Spring do work or not? Spring move or not? Why spring don't move? You're rotating clockwise one. You are charging up the force one. So the spring move or not? So if got move, then got work. So what is work definition? Force multiplied by distance traveled. But must be parallel. So spring got work or not? Got. What is the distance traveled by the spring? Huh? How to calculate the work done by the spring? Can you imagine how the spring move? Before, after spring. The object rotate moment. You already calculate your omega already. Just now. After, stretch or compress? How you calculate the distance traveled by the spring? Yeah, how? From this diagram, how you find? The length of the spring was not given. Huh? Yeah, not given. So how you find? How you find this? Can you link this one to the this? Can you link your S to the this? You're turning this one. So how you find this distance traveled by the spring? How? How? This is very basic mathematics. Yeah.
What need to find the moment, right? As you go to R times segment.
Yeah. Before is, let's say, A point. After you turn, where is the A point? Where is the A point will go? On the disk. So how to find it here? How? Huh? S equal R theta. This is what the question want you to find. Can you see? R was given. Theta don't know. But this is work. You have only one unknown here. Here you have value. You are solving this one. What do you think? What is S? On diagram, what do you understand from what I write on the whiteboard? What is S? Huh?
A prime minus A.
Y8? Y8?
That points A and A prime.
Uh-huh.
A prime minus A. PS dim.
What? Why minus? How you find S again? R minus what? Uh-huh. Then minus what? Why minus?
In that case, you have in A to point A prime, right?
Ah.
Isn't it like A prime minus A
A prime?
minus A?
Yeah. You still finding S? But what is A prime minus A? What is A prime minus A? Huh? What is this? R theta lah. Come on, this is simple logic. You should done better than the secondary school. Simple logic. Okay. So work OX, OY doesn't move anything. W doesn't go anywhere. So doesn't do work. So you only have moment. Moment do work by changing angle. So work we use U. So in your answer for assessment, if you dealing with work, please use capital U. Unless you want to use anything other than U, please write or explain the notation that you use. If you use Q for energy, please write Q equal to energy work done by what you need to explain. If not, use capital U for work. So M was given 5, angle, we don't know. Because angle is the change of rotation. So we have 5 theta joule. Spring, do negative work. Formula for spring, half ks square. Before minus after, but it's still negative. but S1 do not move, so 0. This case is, again, is a simplified case. I already showed you previously, there's one example that is already stretched before start, the one with the slot one. You remember? Okay, this example is a simplified example you won't see in the assessment. Okay, so you get another example. So this one. So your T10 UM by the moment and the spring. So 1.2 ks square. So you put in half k square. K is 10 given. S already show you how to find. S equal to r theta. But remember the square. Some of you know the general formula, but when you go into substitution, you'll forget the square. Don't repeat the same mistakes. So only one unknown inside this linear equation, which is theta. Again, what is the unit for theta? You find this one. Radian. Okay. You need to change the radian into degree. If the question gives you angle, I'll ask you about angle. Once you find radian, change into degree. Okay. But in calculation, you use radian. Okay. If the question asks you find angle, it's like you're explaining to your grandmother who never know about radian. It's like you're communicating to a technician. Please turn this how many degree? Or what is the angle you need to turn? You don't tell technician how many radian, right? Like your worker, they never learn about the radian. They don't know what is radian. You don't communicate. Please turn 0.4 radian. They like, how I know how many radian? Right. So you have to read carefully what the question want you to find. Okay. Again, treat your solution as you're telling a 3-year-old children. Okay. If you don't explain, you don't get marks, right, in assessment. Okay. Next. Same. Before you look at the statement, you look at the diagram. You see fixed point. This rotate. So this one rotate clockwise, 25 Newton meter, radian here. So there's a point here. There's a contact surface. So when you have contact surface, what you have? You have friction force. All right. Next, you look at the question. The wheel given by mass, radius, gyration k. You see k already, what formula you need to call? Nico? When you see k, what formula you need to use? M equal to what? You don't simply pull out the formula. Okay. So when you see k, there is one formula that you need to memorize or need to use already, no matter how. Okay, so k given already, so there is one particular formula you need to use in the solution. Right, subject to clockwise coupled moment, roll from the rest without slipping. So it purposely used the word without slipping. Determine its angular velocity after the center of gravity move 0.8 meter. Center of gravity move 0.8 meter to the right. Why not to the left? Why I say move to the right? Yes, because of the moment given. The spring have stiffness given, initial unstretched when the coupled moment is applied. Okay, free body diagram. How to draw the free body diagram? Ring. What else? What else? Just now I asked already. Before we because you contact with any surface, there is a normal force. Okay. Always have normal force. Friction, it depends on question. Sometimes the question tell you smooth surface, then no friction. Okay. But it's safe to put in friction force. Okay, what else? Okay, kinematic diagram or kinetic diagram, how you draw? Huh? Huh? Okay, good. So you should have acceleration in where? At where? Your MA at where? Yes. So you have omega, you have V, in this case, you can put MA, but if you use principle of work and energy, you're looking at velocity. So in your free body diagram, in your kinetic diagram, you put in V and not A. Okay, so that is the different compared to other section. So if the question point you to use principle of work and energy in your kinetic diagram, you can still put MA inside there, but we are looking for V in your kinetic diagram. Okay, so if you don't put V, there is no marks for kinetic diagram, even though you put MA, because you're not using MA in the calculation. So you're not using anything from there, so no marks. Okay, so we are using IC point. So you have A and IC point. So how to find IC point? You still remember? IC point, we only focus on rod, V, A, V, B. Or you find IC, put your ruler, draw line. This is your IC A. Nickel, how to draw IC point for VB? I did show you VA just now. How? Strong, how to do? Use your ruler, draw, you get your IC point. So that's why your IC at this point, because you put your ruler here, draw. Okay. Don't come to me, ask the same question, Nico. I already explained. So you use kinetic plus work equal to kinetic. So it start from rest, so no kinetic. Remember to write T1 equals 0. Okay, you don't write this one, no marks for your T1. Even though in the next step you write 0 here, I don't give you marks. So T2, again, you have omega. Omega, you give you half IW square. Okay, you're dealing with rigid body, so I omega square. You're using IO. IO equal to IG plus MD square. Using IO. Yeah, okay. Because you are referring to A, you need to find angular velocity of that, okay? So T2, you substitute the value, you'll get 1.02. Okay. Okay, you can take G point. Substitute. Then go start to do work diagram. Which one do work? Moment do work. What else? Huh? Force spring. Okay. What else? Power friction do works. I show you one slide showing you no slipping already. Okay, just be careful on that. In this case, your spring and coupled moment is doing work only. Friction, why friction do not do work? Okay, that one is in chapter 6. Like this. Friction force acting on a round body that roll without slipping. The question purposely highlight without slipping over a rough surface does not do work. But in field body diagram, you still need to include friction force. Yeah? You show you already, yeah? Don't come and ask me, sir, why friction force on the round body do not create work? Okay. If you ask the same question, you owe me a McDonald's. I'll open this slot and then ask you read, you owe me a McDonald's. Okay. Okay. Here, we already explained kinetic, work. Okay, spring, half kx square, right? So moment, angle, all this. In example 2, I already explained how to find the distance traveled by the by the spring, r theta, by radian, right? So yeah. So since the wheel do not slip and it moved 1.8 meter, so it tell you this one move, G move 1.8 already. It means you don't need to find, you can find the angle. Then this one was stretch 1.8, 0.8, 0.18. The S also rotate 0.18. So from there you can find the angle, right? So you find the angle will be 0.2 radian. Make sense? All right. So once you have the radian, you substitute inside. You have your S2. Okay. S2 will rotate 0.36. Make sense? So this one, it will stretch then, but the rotation of S2 A bit different, huh? Okay. Yeah, although the G center of mass moves 0.8, but the rotation traveled by the angle will give you 0.36 meter. The spring will stretch 0.36 and not 0.18. One is straight line. Spring will follow the surface, round surface distance. Okay. Then you substitute everything, you get the equation. Okay, you get the equation omega equal to 2.8 radian with the direction clockwise. Okay, chapter 6, chapter 7, answer must give direction. Must write direction in your answer. Any questions so far? Okay, we go for example 7. Go for one more example. Okay, example, you have a tractor, forklift, lifting a round body here with a something tied to the two handle there. Okay, you're given the mass of the pipe, suspend with two tiles. It gives you the two tiles of the forklift shown in the photo, undergo swinging motion. So when you move, this one will swing with the angle of 30 degree and it start from rest. Determine the normal and friction force acting at each tile that needed to be support the pile at the instant of 0 degree. Means this is the contact surface. There's a normal force, there's a friction force. Okay, measurement of the pipe and suspender are shown. Ignore the mass of suspender and the thickness of the rope pipe. Okay, so this is a composite body with this. Your O point is here, G point is here. So you need to be careful using your I value. Huh? Okay. Right. So straight away, recall principle of work and energy. T equal to work plus T2. Kinetic energy. Again, please write T1 equals 0 in your answer if the question say start from rest. If not, you need to calculate. Okay, you need to calculate the I omega, right? Half I omega square for T1. Determine the normal friction. So your kinetic energy can compute by referencing there are two ways. Either you refer to O or you refer to G. Okay. So this is a ring structure. So your Ig equal to mr square. If you refer to the graph or table, you'll get mr square. Right. So T2 equal to half mv square because of the speed of gravity. Right. So you have half mv square plus half I omega square. This is due to the inertia, second moment of inertia. This one is due to the mass. So rigid body, you need to consider the mass and the moment of inertia. Okay, you substitute all the value, you will miss out the omega. Again, you need to link your V with omega R. V equal to omega R. Okay, remember to change chapter 7, all your parameter, velocity or acceleration into omega and alpha. Okay, that's a trick. Huh? So remember to link velocity, normal or typical or the one you learn in your physics, the velocity with the angular parameter. Okay? Substitute, you get the omega. You need to solve for quadratic equation. Okay, so you need to calculate your IO because your T2 equal to 1/2 omega. IO equal to mr square plus md square. Okay, so I did explain how to get this one in the chapter 6. We'll go and recap. So you get T2 omega square. So you have the work in omega, T2 in omega. You simplify the equation, right? So again, the first section of your question, you always get section A. You'll be forced to draw kinetic and free body diagram. And it will contribute half of the question, 25 marks. Section A, free body diagram and kinetic will cost you 10 points. So if your kinetic or free body diagram or kinetics, you're not able to answer correctly, your answer for B will also very, very, very low because your diagram is wrong already. Okay. So first one, you have two objects. One is a G. You have mass. Once you have mass, you have weight. Then you have a fixed point there, right? So you have a friction force and also contact force. Of course, this one you can draw below here. It's a contact force and a friction force here. Okay. Then you can use the angle, right? So this is the dy that you want to find, because before your y is here, after your y will be here. Your final y will be here. So you need to find the delta y. Okay. So again, normal and friction force do not do work because they are not going anywhere. Weight will do work and moment will do work. Okay. Delta y, you can find 0.4 minus 0.4 cos theta. Okay. Polish up your trigonometry skill because some of you are very weak in your test one. You use the wrong trigonometry equation. It makes you very bad in question 1 or question 2. All right, so you substitute, you get the work done, right? So T10, number 2, your weight only do work because on the free body diagram, these two do not do work. This also don't do work. And here you're not given any external moment. So you only have weight doing work. But weight, where is weight doing work? Your weight is moving down. Your weight from here to here. Your weight actually moving down. So your datum is, your weight is going down. Your displacement is going down. So you get positive work. Yeah. Your weight pointing down, displacement go down, same direction, you get positive work. Then your T2, you calculate already, 63 omega square. You solve for the quadratic equation. This is quadratic, so not quadratic. You cancel the, quadratic, you square it, you get positive, negative. You choose the positive value. But here, you still do not solve for normal force yet. You only solve for omega. Right? So how you solve for omega? You need to use the kinetic equation of motion, free body diagram, this one from 0 degree. So when it reach 0 degree, work at here, 4 meter, 0.4, contact force and friction force, kinetic, you have Ig alpha already. Okay, yes, Ig alpha for rotation, MA going up, right? Then you have tangent also. God, this is a circular motion. We swing in a circular motion. All right, so you have normal and tangent direction. You need to link AN and AT with the alpha and omega. Okay. So you group F equal to MA in tangent direction, you do one calculation. Then you group in normal direction, F equal to MA. You group all the parameter, you solve two simultaneous equation. Okay? And one more. Once you use F equal to MA, normally there will be one more with this moment equation. Okay. In this case, we focus on O. So moment O equal to IO alpha. If you use IO again, IO equal to IG plus MD square. Okay. So you put in all the answers for normal and tangent direction. Moment at free body diagram, this one. Left hand side refer to free body diagram, right hand side refer to kinetic diagram. So moment at O, you put here. We do not do moment. Why? Because it goes along the radius. The D is 0. Okay, so then alpha you find Ig plus MD square. Okay, alpha. Okay. So alpha in this case is 0. So A equals 0, Ft equals 0, An equal to 0.4. So you have all this value. Then you have two, it's mentioned here in the question, you have two tau there. Remember, your final, you need to read carefully. There's one hidden message in the question. Read carefully. Here. Here, suspend from the two taus. So when you calculate at the end, you need to divide the answer in your finding. So your NT, you need to divide by 2 because you have two taus here. Not two taus, the two there. Okay, so divide by 2, the answer is 4.24 kilonewton. Okay, now due to swinging motion, the taus are subject to a greater normal force that it will be in case if the load are statics, in which case NT equal to omega divided by 2. Means in your static class, in your static module, you do not consider swinging motion. You can straight away use omega divided your weight divided by 2. You get 3 point something. So the contact force actually greater if the object swinging. Okay. So this is how you, if the question asks you what is the difference if the case is in static scenario, you need to calculate this one. Then explain what is the difference between dynamic question and static question. Okay, the force, contact force is greater. Or the question give you hints. It was found that the contact surface, the contact force on the tau is greater compared to the static. Prove this statement. You need to show this equation. You do all the calculation, you get 4 point something. You need to write at statics scenario, NT equal to omega divided by 2. Here, you use this diagram. Omega divided by 2 for each of the two arm there. Okay. Okay, tomorrow we will continue conservation of energy and then we conclude chapter 7. Okay, stop here. Okay, Wednesday of tomorrow.